Hi everyone, go run through the TUT questions for week 8 today. Cool, okay, so we've got, for question 1, we have, on the Johannesburg Stock Exchange, the share Steinhoff has a standard deviation of monthly returns of 12% per month. I think I've mentioned this before, but in these questions that we give you, if we tell you that, standard deviation is 12% and, a share has an average return of 2.1%, it's up to you to decide whether you want to define the 12% as 12 or 0.12. It's completely up to you. Just remember that while you're doing your working out, you're going to have to apply this through every step so that you don't mix numbers up. So just be aware that I prefer to write it down as 12 instead of 0.12 because it can get a bit confusing when you start working with probabilities as well, because you don't know exactly if this is the probability or not, or is this the average return. So I like to work just with the whole numbers. So that's how we're going to do it in this TUT at least. Okay, so we have standard deviation of monthly returns is 12% per month, so standard deviation is equal to 12. Let mu denote the population mean of Steinhoff, 2.1%, so we've got mu is equal to 2.14%. Data on the return of Steinhoff was collected over 60 months. Okay, so you've got an n here, so you've got an n is equal to 60. What is the probability that the sample mean return that will be obtained from the sample will exceed 4% per month? So in essence, what we want to know is if x bar is going to be greater than 4%. Right, and so I've just put down that. So we're looking for the probability of x bar being greater than 4. A nice notation, that's how you'd write down what we're looking for. Again, so how are we going to do this? We've got our standard deviation, we've got our population mean, we've got this mean that we're going to be testing, we've got an n, and so we just go pop it into our z formula for mean. So we've got x bar minus mu over sigma over root n. Nice and easy, so we'll have 4 minus 2.14 over 12 over root 60, and that is equal to, so I'm a bit all over the place, we've got 4 minus 2.14 divided by 12 divided by root 60. Are we happy? Yep. And we end up with 1.2. You can do, if they want three decimal places, we'll round to that. Okay, awesome. So now what do we do? Remember, we're looking for greater than. And if we imagine our Z tables, I'd recommend that you do this with every question. You write down what we have. And we want it to be greater than 4, right? So imagine that being 0. That's our standard normal. We want to know that what's the probability of the values being greater than that? So if we look at 1.201. Now remember, the values we're going to be looking up at the table just describe everything from 0 up until the point that we stop, but we want to the right. And so for future note, we're going to be doing 0.5 minus that, because remember, this half is 0.5 and this half is 0.5. Okay, awesome. So table time. And we're going to be looking up 1.20 in essence. So we're going to have 1.20, and we end up with 0.3849.